Hi, everyone, to the Machine Learning Workshop Day 2. Let's give it a minute or two, have people joining. Hi, already see the first people commenting. Just had to mute here. Hope everyone enjoyed the first day yesterday. Hi, Ajay. You can expect another 2.5 hours full of great content, continuing what we or what Ajinkya taught yesterday. Hi, great to see everyone. Hello. Very good to see you again. How did you like yesterday's session? Want to leave a quick comment? Loved yesterday's workshop. Yesterday's session was nice. That's good to hear. Yeah, we will do more of those. So follow us, and we also will keep you posted. All right. Yes, let's get started. So I want to just do a quick introduction, and then again I will pass it to Ajinkya, who's the instructor, who's leading today's session again. So yeah, welcome everyone officially to day 2 of our machine learning workshop. It's a 2-day event. Yesterday's session, 2.5 hours, is available on YouTube if you want to re-watch it. And again, also today's session will be available on our YouTube channel if you want to go back and rewatch it, or if you have to leave earlier and you missed something. So all our content will be available on YouTube, and also follow us on our other social media channels like Twitter, Instagram, or follow us on LinkedIn. We will also continue posting updates and also some bits and pieces from the workshops. All right, so I'll pass it to Ajinkya, who will take over, and enjoy day 2 of our machine learning workshop.
Awesome. Thanks, everyone. Thank you for joining. And without any, let's say, more distraction, let's directly get started with today's content. So yesterday we covered data visualization. That's what we finished with. So today, let me just import the data set as we had, and now rest of the stages of machine learning, we will think about them and we will start covering them now. Okay. So yesterday I asked every plot which we plot, every plot is going to have something which is going to be a relationship between x and y. Okay, so for example, if I plot a plot like this, it is relationship between what has happened, it is relationship between bill and tip with time and day and something. You see, this is the plot I have plot. Here we have total bill against tip with respect to time, with respect to day, and style is differently according to day. So different points for different day are plotted differently here, and we have 2 separate graphs here as well. So as you see, there are, even though this is a scatter plot, rel plot is a bit more powerful than scatter plot. So what we have to get used to is, we have to get used to using the documentation as is. Okay, once we master the documentation, at that point what we have is, we have a extremely powerful way of searching anything which we want. Okay, so all the libraries which we are going to cover, all of these libraries API is available, and we have to learn to use the documentation correctly. So I was reading some tweets about people who wrote the products like App Engine on cloud, or even open source Hadoop databases or something. And they were saying that even though they invented and wrote the code of the technology, they still have to look up documentation. They still have to do Google search to look up what they are doing. So as this is just to give you that, Googling is Googling is the default way. Okay. So you have to learn to do Googling, and you have to start doing these things by yourself. Okay. So now going back, this was the document which we had shared yesterday. And the document is, I have already shared. It is VUSATE. And this document you can kind of like use as is. Okay. All the code of yesterday's are here, and all the code for today's is also here. So it's going to be combination of hands-on plus some more bit of understanding related stuff, because you see, we have lots of training courses out there who are just focusing on syntax. What we lack is a comprehensive picture in which we see everything in a conceptual manner at one place. So there is a framework for a 7-stage framework, which is quite important for developers if you want to develop that. And if you want to go into detail of each stage of the framework, I have another document which I have shared in that Evernote. Okay. So you can see that document is part of here. So this is here, that document. So if you open that link, it is gonna tell you at stage number 1, what does it have? At stage number 2, what does it have? At stage number 3, what does it have? So all of such things is a part of the 7-stage frameworks of machine learning. And when you learn the code of every stage, that's when you are mastered. So I will edit every stage, and I will change, I will append every stage with a library which is suitable at that problem statement. Okay. So this is how we are going to have, and let's just continue with the deck for today. So this is the 7-stage framework, and in checklist, we have seen problem definition, we have seen data collection, and we also saw data visualization. Data preparation we did not see. I'll maybe just share the code for that with you, and you can get that details, and you can just work on them. Now you see, in terms of importance, the most important stage is generally assumed to be ML modeling, and it is true. It is the most important stage, but in terms of most time consuming state, this stage is the most time consuming. The most time goes into data preparation, data cleaning, data integration, wherein you have data available at different places, you just put all of that into one place. So there are lots of things which are kind of like going on whenever we have a thing like this. So this is the most time consuming, which is data preparation. Then we have ML modeling, which is the data scientist job, which is generally thought as the main emphasis of ML. Then comes feature engineering. So this is most time consuming. This is most impactful. Feature engineering is quite impactful because any impact done by feature engineering is going to make a lot of difference to the final product, which is nothing but machine learning model. Okay. So it's the feature engineering which is important, and we have to learn to do that feature engineering. And once we have taken care of the left hand side, then we actually take the project which we have done, and when we create a project out of it, it could be a website, or it could be Android app, or it could be an application which is desktop application, or it could be anything else. So we take the model which we have developed, and we create a model in real life, the model which is actually used by the world. We do that for us. Okay. So this is how the stages are. This is how the entire comparison, entire stage framework looks like. And when we follow this strictly, one, after we do this one, it is like an illumination criteria. Many times the business problem which we are trying to solve is not a sound problem. So from there, we should, shortlist a few projects. Okay. This, in terms of problem, we have 3 things. One, we have to check if it is possible, and we have to check if it is profitable. These are the 2 things. If there are 2 ML models which we can do, and in terms of time consuming, one model gives you more profit in less amount of time, of course, that is the one which we should prioritize. It doesn't mean that we have to not do the problems which are not that profitable. It's just that we do them a bit later. It's the business we prioritize, and then we slowly go to the next stage. So after problem statement is done, then we go for the next stage, which is data collection. And once we are into data collection, we have to understand that if we don't have data, if we don't have labeled data, we do not have anything. That's why there is this quote which is really popular for ML. The quote says garbage in, garbage out. So if my ML model is not that great, if my ML model is actually, let's say, giving me errors, then it kind of like makes it look like, my ML model is not that accurate. Okay. But in that scenario, it's not the ML model which is the problem. In that situation, the problem is not the model itself, but the data. It's the data which is garbage. So there is this XKCD comics. On this comics, I really loved this comics from it. So it says about, okay, how is the ML machine learning system? This is the new person asking a data scientist about, how does your system work? Okay, so this is ML system, and what does machine learning do? This is the intro to ML. We have already done that. So what is intro to ML? Instead of actually giving rules manually, instead of developing the code which is going to uh, instead of doing the code which is going to, let's say, actually transform A into B, we are going to give it data, and from the data we are going to get the output. Now the most obvious question is, what if the answers are wrong? Right? You see, whenever we are doing in a non ML way, okay, so in non ML way, answers are fixed. We know the stages, we know why something has come, we can debug it, and we can fix our how something has come. So answers are determinate more than fixed. We should call it are deterministic. This system is deterministic, sorting is deterministic. But when we are doing stuff with ML, which is nothing but a statistical modeling based on the data, for ML we actually might have wrong answers, and we don't even know why the answers are wrong. So many a times, the thing which most people do is like they just train or try a different model or try different things until something starts working. This is how things are. In ML, it's all about data. We do all of the work, all of the experimentation on the data until we start seeing something which is correct. And it is how it is. There is nothing which is wrong with it. That's how machine learning is. Okay, there is no such thing which can kind of like make it different. So I don't know if you know this person. Just a second, I don't know what is. Oh, yes. So this person is Jeffrey Hilton. He's father of deep learning, and that's me besides him. So I had attended his session, and I had actually asked him whether in machine learning system, why are we still not able to understand why something is the way it is. So he said machine learning right now is an experimental science. It is not we don't know the explanation of something, why it has happened or why it has not happened. In a time when the technology improves, we will actually reach a stage where we can explain why something is working and something is not working. But until we reach there, it is a experimentation science, and we have to keep that in mind, that we are do using a thing which is experimentation science. Okay, so that was the kind of like stage one. And then we have to collect the data. That is what I talked about in before. Then after we talk the data, we have to do the data cleaning, and then we have to do the data visualization. So data cleaning and data visualization, these things are very important. They allow us to actually understand what is present in the data, and if there are mistakes or noise present in the data, then the with help of the coding which we do, we actually remove those errors from the system. Okay, so it was data preparation and it was data visualization. And then once this thing has been done, we actually move forward. We actually move to machine learning modeling. So that's the next stage of the evolution towards the solution which we are trying to build. Okay, so before we do that, let me just quickly take the data preparation part which we had missed yesterday. Okay, so let us just try to do that now. Yes. So this was the data collab which we had created. Let me just upload a notebook here, and the notebook which is nothing but data preparation code. So data preparation, let me just upload one notebook, and let us talk about data preparation in, instead of NumPy, let me just take something else. So once we collect the data, then we have to actually process the data. So there are two libraries for doing data processing. One is NumPy and other is Pandas. Today, let's not go for NumPy library, but the path, the collab document where the code will actually be present, I will share that in the Evernote document. So right now, this data preparation part which we are going to cover for today, let me just share it, copy the link, and you have this stage 3 here. So this is the collab. So now if you are interested, you all have the document with you. You can follow the code along for stage number 3 with me. So you see, once we have the data, what we are trying to do is we are trying to do data processing. Okay. For example, yesterday, remember here in the tips, this was the tips data set, right? So I could create something like this. So I could say, okay, I want to understand how what the data is. So I could be executing tip.head. So in when I say tips.head, I actually see what kind of data is present in tips data set. I could do tips.info. There is another function. Info stands for information, and all of these functions are from, again, Pandas library, a documentation. So if you go to Pandas documentation, this will redirect you to the official website, and this is what we should be referring to. Right now we have API reference of Seaborn, now we have API reference of Pandas, and once we kind of like handle and master this API reference, we know all the stuff which we need to know, and we know where to look it up if we need it. So in Pandas, you can see there are these common sections: input, output, reading the data and saving the data, general functions, functions related to data frame, then function related to Pandas array, accessing, group by, some general functions. We have data cleanup. You see, these are the stuff we have to do. Deal with missing data. If there is some missing data, what do we do with that? If there is some wrong data, what do we do with that? If there is some mistakes, what do we do with that? If there are some wrong data types, how do we deal with that? These are all the questions which we have to ask and get answers to with help of Pandas. So any kind of like data set we have, we take that data set and we start executing these functions to understand that data better. So sometimes we have to do functions like this in data frame. We have to do indexing to find out what kind of data is present. We can do some re-indexing, maybe to organize the data better. We need to do reshaping. Sometimes for machine learning, I need to decide, okay, I have 5 columns. I'm going to use them to predict something, but out of the 5 columns, there is a problem, and I need to sort out one problematic column. So I can either delete that, or I can combine that with something which is useful, or I could be doing anything. So this is the data frame related questions. Then some bit of pandas arrays and blah blah blah. So as you can see, it's pretty comprehensive. So in the beginning, you don't need to know all of this. You just need to know few functions which are more frequently used, and a few functions. Then once you master them, then you are actually ready to do at least most of the stuff which is present in ML. Okay, so let's just go into the Pandas documentation. If you open the link which I have just created, you can simply find out how to do it yourself. So I'm executing this. I'm importing Pandas libraries as PD. These are the general universally accepted norms. Import Pandas as PD, import NumPy as NP, import Seaborn as SNS, import scikit-learn as sklearn. You see stuff like this. These are all common norms. So we have some important functions here, which is kind of like, let's create this series here like this. Okay. So this is the Pandas series. This is nothing but array. In programming terms, array is nothing but list of few elements which we can use maybe to store or something. This is the list of the elements we have with us. Okay. Now, once we have data with us, how do we process that data and what do we do with it? That's another question. So if we have the data, what do we do with it? So that question is of how do we access that? We access it like a square bracket. So if the array was like a different array, in C, Java or something. Oh, let's see, you are unable to access. Let me click on share again. Copy link. You should be able to view it, but just in case, let me share it one more time. Okay, so I've copy pasted it now. I am syncing the data again so that immediately the changes are synced. And I am opening this into incognito window. So copy here. Let's just, open it in incognito window to see if the access is fine or not. So yes, the access is there. So nobody should have any problem accessing the document which has been shared with everyone. Okay. So we have the access running. Let me close this. Let me close this as well. Okay. So going ahead and talking about data preparation here. So we have this thing. This is how we access. This is how we access the data. And you see, when I execute this, I have set up some information, and I can kind of like simply say, okay, get me something. So if I do square brackets and index, I give the stuff, I'll get the results. Okay, so what it could be anything, there could be anything here, but I'm getting it as is. So you see, let's say here I set it up for, let's just say instead of apple, let me make it mango. Right now monsoon is started, so it's no longer time of mangoes, but as you can see, index is mango. The series has value corresponding to mango, which is 19. Okay, so this is how the stuff is. If I want to return multiple elements at one time, if I want to return multiple elements at one time, then what do we do? So then we kind of like simply can make a double square bracket. Okay, yes, we can overwrite a lot of data. So pandas is nothing but an array. We can do anything here. We can do transformations, we can do any kind of like changes. It is fine. So that's why we can do data cleanup here, right? So here in the mango, I can make it as no more mangoes, drink fruity. So let's say I execute this. Okay, so what I've done, I've done x is equal to y related stuff. I've done that. And when I say I have transformed it to this thing now, a different thing. So I'm doing series 2. So if I simply do series 2, it will print the entire thing again. Okay, it will print the entire thing again, but we don't want to print it as is. We want to just print stuff related to mango. So I could do series square bracket and the index mango. Okay, and if I do that, it will print me whatever the details was there. If I want to add something, I could do that. I could say series 2. Here I could say 5. Let's say 5, and then I could say 20. So this 5 will act as a, okay, index. The index is not present. This 5 I have to create as a string because I have created it as a string. So you see, this creates a new index. So it's like I have created another column here, and for that column there is this value. So this is how pandas actually works. It is very easy. Syntax is quite intuitive, and once we get used to using pandas, I would say this is the library where anyone as a beginner is going to spend most time in. One, it is easy to use. Two, it is very frequently used. So you have to master this pandas thing. You don't have to know all the functions. Okay, you have to know few common functions. So I would say sampling is important, grouping by is important, windows is important. Then we have some date conversions that is important. Then we have to do in data frame conversion is important, indexing is important, function these are important, computation and starts is important, missing data is important, reshaping is important, combining and joining is important, series related is important if you are working with a time series data. Okay, so these things are important. And as long as you know these things, data frame related function and some date related functions, that's more than enough. That is more than enough. You don't need to know have uh, anything else beyond whatever we have until now. Okay, so that's it. So going back to the collab, so if I want to return multiple elements, pandas has this thing which is double square bracket. Okay, so we actually have a double square bracket and it returns multiple elements. So I have apples and this thing, and for mango we have this thing. So what I'm going to do for mango, let me make it 20 again because I want them to be numeric. And here, if we do the series mango thing here, so you see the result is 11 and 20. This is how you can have kind of like multiple elements access in pandas. You could also have something which is comparison here. Okay, so comparison, is it like this or is it like this? Yeah, it is like this. So I have condition, it says, okay, which ones are greater than 15? This is greater than 15. This is not greater than 15. I can actually also do comparison inside. The comparison inside, if I want to do, the syntax of that is like this. So series 2 and greater than 50. So you see, the way this thing has written is like I am trying to return all the values of the array of the data frame which are greater than 15. So this is how this syntax actually works, because there is string we are having problem. So let me check somewhere down line. I have the same syntax, but for numeric one. So I'll share that with you. But this is how the syntax is. The comparison and is kind of like, this is how the format of pandas is. So I will share that with you right now. Because of the string we are having some problems. Anyways, let's skip. Let's go forward. Then we have, yeah, this is the condition. This is the condition. So you see here, when we do this, this is how the comparison was done. So all the values which had value greater than 12. Now when I did sub indexing, that's when this thing was not working. But this is how it actually works. So more you spend time on doing the data processing, finding out what kind of values are present where and how you can get those values. More you do that, more you will get hands-on experience of pandas, and more you'll be able to actually implement these things by yourself. Okay, so this is how the series actually works, the pandas actually works. So then we have stuff like this, if I want to do some transformation, multiplication, or if I want to create some processing function. So as you can see, if you go through the whole document, you will have a lot of functions which you need to know. So we need not go through the whole thing today. We will, go to the important part, which is like machine learning modeling. We'll spend more time on that. So you see, please go through this document and just see which one you like and get used to using this function. Okay, so going back, we have the slide deck. Okay, so the ML machine learning modeling. So the common thing which I have heard, which is the most frequent problem, is in machine learning, whenever you start actually coding stuff, what happens is, like, instead of coding, you are stuck in maths. This maths is like the not this is the kind of like thing which is the most difficult for most people. And whenever we try learning these things, I used to do this course, Andrew Ng's Introduction to Machine Learning. And in that time, many of the courses do say that, if you don't understand it, it's okay. You don't understand, it's okay. Then what happens is like you believe them. And after you believe them, you go ahead and things become more and more and more complex as time goes. This keeps on happening always. Things never become easier. Okay. Sometimes, the maths part is so complex that it kind of like goes like this. So the maths part happens like this. It talks about mathematical part, and it says, oh, this is how the prediction is. This is how the cost function is. This is how the stuff is. So there is a difference here. The term, meaning of the term, and its formula. These three things are different. And there is a fourth thing, which is understanding of the term. So once you know the term, its meaning, its understanding, also its impact, its consequences. Once you know all of these things, at that time, even if you don't know its formula by heart, you are fine. You have to actually focus on important stuff, which is understanding, and then next important stuff, which is implementation of the understanding. Once we do that, then we are actually in a very capable stage of actually doing projects, completing them, and maybe getting hired. So for that purpose, you don't have to do lots of courses. So if you are simply doing lots of courses and you think that simply because of certifications and you will become data scientist, that's not true. You see, I started learning data science back in 2015. We have Nidhi with us. She also started learning data science, I think 2017 or 16ish or something. You see, once you follow the right path and when you actually understand the concepts thoroughly, then you can become the data scientist. So you have to do few courses deeply rather than a lot of courses shallowly. That's when you kind of like, have a true knowledge. Now, going back to this thing is like we have to, while doing the coding, we also have to understand difference between a researcher and a developer. So researcher is somebody who invents something. So let's say we have Einstein's theory of relativity. So Einstein's theory, so few people even understand it, let invent it. So, but we don't have to invent it because that's what Einstein has done for us. He did the part of experimentation, and then that theory is available for us to, directly use it. We have to use the theory and develop applications. So right now, the most frequent app everybody use is, maps using GPS. So Einstein's theory of relativity comes into picture whenever the GPS is like we have Earth like this and we have satellites which are orbiting around the Earth. Because Einstein's theory of relativity says if you are at a really high speed or you are near a gravity whose force is high, this thing changes time dilation. Okay, so time passes slowly. So the satellites, they are quite near Earth. Earth is quite huge. So before application developers considered Einstein's theory of relativity, the maps were not very accurate. GPS was not very accurate. Whoever kind of like did that offsetting, they simply had to understand Einstein's theory and follow it. Even if they were not the one who invented it, it was okay. So in terms number of jobs, researcher jobs are quite less, developer jobs are quite more. And anyone who is following this video, I would really recommend you to look at what you want to become. What you want to become, whether you want to become researcher or a developer, I would recommend developer jobs are quite more, and that will give you a lot of opportunity. Okay, so we have this thing is like it is saying libraries are not a substitute for understanding. Many of the courses just focus on syntax. They say, oh, call this scikit-learn library, call this function, and your model is done. Use the random forest, and then your accuracy is high. These are all nothing but just using buzzwords without any deep understanding of them. Once you have deep understanding, then you understand syntax is not enough. Someone is just blindly shooting. You have to actually have something which is quite accurate. Okay, it has to be quite accurate, and it has to be useful to whoever is, let's say, following it and building it into the solution. Syntax is not enough. That's one, that's must. Okay, a data scientist has to have these things like this. Every time we have a different problem. Okay, every time we have a different problem, and for that different problem, data is going to be different. For that data, the solution is going to be different. But while building solutions, we have different constraints, we have different trade-offs. So these all things need to be considered. Only then we can arrive at a right solution. So ability to decide accurately based on the given data, constraints, trade-offs, based on that situation. That's what makes a data scientist. So we have Prakash, who is a research scientist, and many of the products has been deployed into production. So you can ask anybody who is working in a real data science project. They can actually tell you how important it is to do this, understanding all of these things. Okay, so just problem solving isn't enough. Problem solving is the first step towards being employable, but just that is not enough. We also need troubleshooting ability. So troubleshooting ability, what do I mean by that? So troubleshooting is like whenever you are solving a problem, you will face new problems while trying to solve that problem. That is the troubleshooting part, because that's the bugs. Bugs are very common. Okay, bugs are very common. So we have to be able to solve those bugs, find out the bugs, and debug them, and blah blah blah. So that's what's the debugging is. We should be in a situation to be debug the mistakes we face while solving the problem. Okay, so that's the kind of like one important thing. Then another part, which is thinking about the business impact. I mentioned it yesterday in the beginning. I said we have to do problem analysis, but let me just elaborate a bit more on it, and let me just talk about what does it mean to think about business. Business means it is nothing but we are taking a look at our solutions impact, and if that solutions impact is good, and can I sell a solution out of it. For example, let me just talk about this example I've already mentioned. Chess in 1997, Gary Kasparov lost against Deep Blue, IBM's computer. Okay, IBM's, Intel's, whatever. So it's like it lost against Deep Blue. And then the game which was the next frontier, it was AlphaGo. Okay, so AlphaGo was extremely popular. So this game is in the chess. Chess kind of like considers a lot of brute force thing. The previous problem, it was a brute force problem solution. But if you are using AI is a much more efficient. So AlphaGo was a product by DeepMind, which is company owned by Google. So it is not a brute force thing. It does not consider all of these things. It is quite close to intelligence. Okay, so hundreds of moves, 100 times worse than that, but our brain is very optimized. So a machine getting as close to us is a great thing. So that's what happened. Now what I want to talk about is I want to talk about what does it mean to have a business mindset. Remember, we started this thing as it's business. So business impact. So how does it mean? It means two things, combination of two things. Develop as a developer. We have to solve the problem, but we also have to think as a businessman. Okay. So chess is a professional field. There are companies which sell software for chess. Okay, the engines, they are open source. Engines is nothing but a engine which we can practice against. It's a computer software to learn chess for. Now they all have engines. There are companies which sell services for it, company like chessbase, or there are other companies as well. So we can use this software which is AlphaGo, which was developed by Google. We can use that software and actually build a very amazing product which is using AI. Or there was a news using in Google's data centers. Google actually led to around 30% saving of power by using machine learning. So when machine learning was done, rerouting intelligently the demand, Google could achieve a 30 to 40% this thing saving. This was again done with DeepMind's this thing. So the AlphaGo related project which we have, that same project was here used here for this thing. Uh, Imagine what we could do to use the AlphaGo and develop products for, let's say, saving power of countries or continents, or we develop applications for targeted for a sport like chess or shogi or go. When we think about the product and its applications in real life and how we can code it ourselves, then we are actually thinking as a businessman. Our value, our project, our work is valuable to others. And where is this project available? We have multiple companies who have made their solution open source. So AlphaGo is Facebook's. Leela Zero is a open source thing. So if you search AlphaGo, this was a implementation for same thing which I talked about. This is that implementation on the Go thing. This is one of the most intelligent things out there, and it is available as open source. Okay. Or Leela Zero is the same thing. It is available for Go, it is available for chess. This engine actually beat all other engines. This engine beat all other engines. That's how high quality this was. And we can start using that. We can use that because ready-made code is available. So we want to do that. We want to we want to be in a position that our work is useful and we can sell it. So machine learning should not be just isolated. Machine learning should exist with how the rest of the world is moving. Okay. So let's see. Now let's go into the coding part and let me just clarify one common confusion. And once we clarify that, we will take a look at the coding part. Okay. So it's like, as you might have noticed, I love watching movies. So this is my honest opinion that whenever you are trying to learn ML, please prioritize by solving problems. Prioritize by solving problems. This will help you a lot. Okay. So going ahead. So yesterday I was talking about detective movies. And many a time in detective movies, what we have is we have detective, we have multiple people in the room, and we have one murder, and we have one murderer. So here, through the entire movie, so entire thriller movie, over time duration, detective finds out the murderer. From the beginning, the detective does not know the murderer. The murderer is found out. It's the same thing here. So the butler did it was a kind of like thing. It was like a finding out. It was the butler. It was the waiter who murdered something. So it's the same thing in ML. It doesn't matter what kind of problem statement we have. We have to learn a general framework through which we arrive at a final solution. So the final solution is found out. It is not known beforehand. Final solution is found out. It is not known beforehand. This is what we have to know as a must thing. We have to learn how to experiment, how to find out, how to evaluate. Once we know all of these things, only then we can actually understand how to do the stuff ourselves for any kind of like problem. Okay. So let's start with a bit of coding part, and we will be able to in a position to actually do it ourselves for any other kind of like problem. Okay. So let's see. Let's talk about just thing. What is AI? AI is nothing but statistical modeling. Okay. What do I mean by statistical modeling? Based on patterns in the data, you can actually predict patterns in future. You can predict value in future because you knew the past thing, right? You knew past, and that's why you know how it is gonna be there in future, right? So it could be accurate, it could be a bit inaccurate, but that is how machine learning is. It starts with pattern matching and we write the code for it. So that's it. Okay. So let's just go for hands-on coding. And in the coding part, we will focus more on some stuff like this, which is the coding part. Okay. So let's go for collab. Let me upload the notebook which I have created as experimentation and share that with everyone. Okay, the upload is success. And let's go to Kaggle. Okay, so stage 5. This is the collab link. I have started syncing thing in Evernote. So if you simply refresh your page, you should see this link in your Evernote notebook and you can follow it along. Okay. So what is machine learning? Machine learning is nothing but prediction based on data. Machine learning is nothing but prediction based on data. Okay. So let me just start from the previous slide. Let's just go here. So we have stuff like this. We have data. We have data which we have compiled from for whatever problem we have. Let's say problem is, let's say I want to buy a house. Okay, we would ask around and find out what is a suitable price of the house in corresponding property. It's like, if we don't want to be told a much higher number than what is in reality, that's why we will ask around. But let's say there is a retail company, and retail company's entire job, not retail, sorry, real estate. Real estate's entire job is buying and selling of properties. So they have to have a very good accuracy model. Okay. So they need to have past data, and past on that data, it is going to create a machine learning model which will predict the value from patterns learned in past. So this is what it is. Anyone who has spent a lot of time doing something and they have mastered something, then they actually have a very good, let's say, idea about why something works the way it is. So some people who are top in finance, okay, they'll definitely know things which are contributing to a certain decision. They will know, oh, the market is going to crash or not crash. This is the likelihood of this thing happening, and this is the likelihood of that not happening. All of these things are known to the person, right? Machine learning model learns in the same way. As long as we give it enough data, it can learn. Okay, but then we are starting with this part. What is a loss function? Loss function is nothing but, instead of loss function, let's take a look at error function. What is error? Let's say I have a predicted value. I have predicted value and I have actual value. I could be doing it in a different way. What I could be doing is like, oh, let's just do this thing. Let's have, A minus B. And I do predicted value minus actual value, and that is my error, right? So that predicted value minus actual value, that is my error function, and that is the error, right? So when I minimize the error is difference between predicted minus actual. When I minimize the error, my predicted value comes as close to the actual value as humanly possible. So you see, the prediction here is extremely accurate. Prediction here is extremely accurate when error is zero. That is what we are going to do in ML. Okay. So in maths terms, it looks like this. Let me just directly jump here. So in mathematical terms, it looks like this. The input data is X, the value to be predicted is Y. Okay. The model which we choose, it's kind of like a Y is equal to Fx. So this is my chosen model. Okay. Then once my model is chosen and it has been trained, I kind of like, use that model, the F model on the data, and the output is actually the predicted value. So Y actual minus Y predicted is the error. Okay. When I am predicting value of Y and Y is a number, this thing is called as regression. If I am predicting value which is numeric value, this thing is called as prediction. Okay. Prediction, sorry, this thing is called as regression. So we are gonna see regression in the coding. Okay, so let's just see that, and let's simply talk about, take a look at the slides for that scenario. So it is 4 step. We have data, we have model, we train the model, and then we use the model to do the prediction. So I have input data, we have model, we train the model, and we do the prediction. I am doing that on number. Okay, so let's do that here on regression. Okay, so this is the regression thing. I am importing few libraries which are important. I am predicting a few values, and let me create a fake data. We are going to use that data to evaluate what how my machine learning looks like, right? So let me just import this thing. So import numpy as numpy, matplotlib as plt, and something. And we are creating data like this. Let me see if this thing is shared. Yeah, it is shared. Okay. So I am creating data here. I have created fake data here. How does this look like? This looks like x is equal to 1 to 9, and from 1 to 9 we have to create, then I create y is equal to x plus 1. Okay, so I'll execute this and let me insert a new code here. I am saying print x comma y. Oh, I actually had the print statement anyways here. Okay, so I'm executing this print here. So values of x is from 0 to what? 0 to 8. Value of y is present from what? 1 to 9. Maybe let me change something. X is y is equal to x plus 10 instead of 1. And let me print it again. So for 0, I have 10. For 1, I have 11. For 2, I have 12. For 3, I have 13. And as you can see, it is obvious, right? So let's just, this is nothing but how I'm creating data. So the library which we are using here is NumPy. Okay, the library which we are using here is NumPy. And what are the libraries we have used until now? Let me just make a list of all of those libraries whose API which you have to know. Let's see. Let's go to Evernote. In the Evernote, let me create a section. Okay, and let's insert a table. Okay, so stage 2 was data collection, right? For data collection, the library was Beautiful Soup. Stage 3 was data preparation. For that, library was Pandas and NumPy. And whenever you have a question on what something is, you simply look up the documentation. Okay, you simply look up the documentation and you start using it. Right now, I have shared the documents in Google Cloud. Sorry, Google's Colab product, but that is not what you will do. Okay, so you please install Anaconda. Okay, install Anaconda software, and once you install Anaconda, use Jupyter Lab notebook locally to do the coding yourself. Okay, and once you use Jupyter Lab notebook, that's where it will be your home for all AI related stuff. Okay, so in the AI related stuff, once you open the notebook, that notebook looks like a Python thing. It does not look like Colab. So this is how the Colab looks like. It is easy to share. Okay, it is extremely easy to share, but there is it's a bit, features lack a bit. Here, let me just open Jupyter Lab. How does Jupyter Lab look like? It looks like this. Okay, and let me just open the machine learning regression part here. I'm minimizing this. Anytime you are stuck with what is this function doing? Okay, anytime you are stuck with what is this function doing, remember, I would really recommend for you to organize your workspace like this. Open a notebook, then click right click. Okay, click on show contextual help. Okay, and then drag this like this. So once you do dragging, your window is divided into two parts. Left hand side is the code, right hand side is the help. Okay, so you see, when you do right hand side, you can simply click on the function and its help will be available immediately here. So I am doing right click, and okay, I think I need to import. I execute this. So I executed this, and okay, so you see here the help is immediately given on the right hand side. So anytime you have a question about something, oh, I don't know what this function does, I don't know what this library does, I don't know how to use it, you can use it from here and you can use it to experiment. I also like to create another thing, which is right click and create new console for notebook. And I like to drag this on here, which is below contextual help. So on the left hand side, I make a big code part. On the right hand side, I do this thing where I can do any kind of like experimentation. Okay, so I executed this. If I want to see what is present in X, I can immediately find out. So any quick coding I want to do, I will use this right side bottom part. This thing we can't do in Colab. In Colab, you can also can't do right click and you can't see the help. That's why, you know, Jupyter Labs setup is very important to know. But it is Colab is a good way to share, and you don't need any computer for yourself. You just need a Chrome browser or any kind of like browser, and you can get a good RAM machine to execute for free. So that's why we use Colab. So right now you see I'm using around 12 GB of RAM and 100 GB of hard disk, and if needed I can also insert GPU here. So you don't need a powerful laptop. You can do machine learning or deep learning from Google Colab. Hence, one of the easy ways to use. Okay. So contextual help is this. So going back and going forward to the code. Okay. So let me just now print X shape, Y shape. So as you can see, X and Y are nothing but arrays. X and Y are nothing but arrays. In machine learning, one has to know how X and Y should look like. Okay, let me open whiteboard here. Whoops. So X and Y. Okay, so we have X and we have Y. Y is the one which is being predicted. Generally, it is single column. And how Y looks like in terms of matrix, if I'm using matrix notation, it looks like M comma M by 1. It is a column, single column. So y dot shape is nothing but a shape is nothing but numpy's and even pandas function. It gives you how what is the kind of like matrix representation, number of rows and columns here. It is going to return m comma 1 because it is only one column. X is columns which are being used to do prediction of y. Generally, there are multiple columns. Okay. So when I do shape of X, it is generally also M comma and it's like number of columns. Okay. It is also shape and it is number of columns. So when we take a look at the data which we created, which was here. Mm, My laptop has my laptop has crashed. I'm just waiting for my laptop to become responsive. Just be patient. Let's see. Okay. Yes, it has become responsive. Cool. So we have this thing here. So when I print x dot shape and y dot shape, it gives me 9, 9. It is nothing but array. So what I have to do is like this is how I have to use the reshape. Okay. So x has to be in the shape of m slash n, where m is number of rows, n is number of columns. Here, number of columns are 1. So we have to get it into format of 9 comma 1. You see, this is the mathematics and overlap of machine learning and maths. So linear algebra and maths are kind of like overlapping here. Scrolling down, there are different ways of doing reshape. You know, if I give a argument of -1 to something, it what it understood starts that okay, whatever was the previous value, keep it as is. Whatever was the previous value, keep it as is. Simple, right? So that's how we can use numpy dot reshape. And you know, let's not worry about it. This is how the stuff is. Okay. And let's start machine learning from here. So how do we do machine learning? Let's go back to slides. Slides. Okay. So you see, it is data. And what we did until now using numpy, then reshape, this was all preparation of data. This is what stage number 3. That stage to actually prepare the data so that we can do machine learning. It could involve, okay, maybe delete the unnecessary data, maybe remove the wrong data, maybe combine data from multiple sources into one. There is a lot of work involved in data preparation and we have to do all that. So we did data preparation. Then we do data visualization. But here the data is very simple. So we are not doing that much visualization. But maybe I'll show you. Okay, this was data visualization. So when I do plt.scatter, we see the data is extremely linear. We see there is a direct relationship between x and y. Hence, we know it is a simple line. It is a simple straight line which we can use to do prediction. So for example, if there is a share price company and for share price, we actually have a graph like this, then we know what is future price of a company going to be. And I could make maybe a lot of money. So that's the kind of like model. we are choosing linear model. Okay, this is the model. And once the model is chosen, I have to make the model learn from the data which we have given to it. Okay, I know this is a lot of words. If you are first new to machine learning, I am sure you would be confused by what is happening. Okay, uh, because there is a lot of terms, and these terms are kind of like confusing if you're new. So let me just talk about. Let me just talk. Give another example. Okay, let's take a problem. Let's say you are a real estate company. Okay, and you do house buy and sell. You see, many a times one of the common ways of making money is like you buy something, you hold it, and you sell it. Okay, so how do you make money by buying and holding and selling? If you know in future the price of the same property, if it is going to increase, you'll buy it, hold it for that time, and sell it. If you know something, some property should be actually evaluated to, let's say, $1 million, but maybe owner is in rush and they really wanna sell their house, and they're selling it for $0.8 million. Okay, so if you can find underpriced property, you can make money by directly buying it and selling it, or you can do buy, hold, and sell. Right? To be able to make money by just doing this, you need a accurate representation of what the price is going to be when you sell it. Right? That is exactly what the problem is. We are predicting price of the house, and to do that, there are lots of problems on Kaggle. So Kaggle is a place where you should actually be all going. You should all have account on Kaggle, and you should all be using and participating competitions on Kaggle, because extremely useful. So what is Kaggle? Kaggle is a place for all data scientists. So it's like Facebook for data scientists. So let me just open this thing. Okay, let's go to Kaggle, and on Kaggle, open competitions, and in the competitions, we can check the active. This is house pricing competition. Okay, this is the exact same problem I just explained. We have house. We want to predict price of the house. There could be lots some you can practice it here. If you click on data here, you see there is only how much data? 1 MB of data. How many columns? 163. What do they all have? They have details like this. Okay, what is the lot shape? How much alley? What street is nearby? What is the condition? What was the year built? What is the maybe style of the roof, style of the exterior? Lots of things. You see, this is the data. And if you create a ML model which gives you good enough accuracy, you will get a good enough rank on this competition. This competition is very old. It's been going on since 6 7 years. But there is another competition which had the same problem statement as this, which is Zillow house price prediction. You see, this is regression technique. 5,000 people participated here. It has been going on since 6 7 years. If you go to Zillow housing price prediction, it is the same problem. You are predicting price of the house. This competition was available 2 years ago. The winning price of this competition was $1.2 million. A $1.2 million. So that's the financial impact of a good ML model. When you have a good model, you get a kind of like good accuracy, and that accuracy makes a lot of business impact. So that's the coding part. You see, the data is similar. How many columns we have? It's 1 GB data. So we have 145 columns, but lots of rows. In this, we have very less rows. How many columns we had? We had 163. We had more columns here, but less rows, much less rows. Here we have a lot many rows, more than millions. And that's how we get good accuracy. So to be able to do that, we need to understand what is machine learning first. Okay. Hence code. Okay. So right now what I did, I simply executed. Oh, let's import linear model from scikit-learn. How do I know what model to import? I simply have to know scikit-learn API reference. You see, this was data preparation, then stage 4 was data visualization, Seaborn, then stage 5, machine learning. We have scikit-learn. So all of these libraries, we just have to directly go to their API. So Seaborn scikit-learn API, this is what I want to go to. So I'll search scikit-learn API. This will redirect me to its API reference. And this is the API reference, the whole API reference. What all classes are there, what all functions are there, what clustering. Let me simply search linear. Okay, immediately I know linear modeling is here. I know these many types of linear models are there. I'm simply using linear regression. If I open that and if I scroll down, I can directly see the code as well. You see, by simply spending time on the documentation and roughly getting an idea of where what is present and thoroughly understanding few very frequently used functions, you actually become a practicing data scientist. So this is what it means to have a hands-on knowledge. Okay, so hands-on knowledge is must, and we are going to continue with going through this notebook, and you guys all can do the coding. But for now, let's just take around 10 minutes of break. During the break, if there are any questions, we will take. I'll answer questions on chat. Okay, but just need a bit of coffee. So you also guys can walk around. Let's take around 10 minutes of break, and you can ask questions, and I'll take the questions. Let's see. 10 minutes timer. Okay, the break has started. We'll resume in 10 minutes. Awesome. So we are back. Let's go back to code and let's see. So I'm just taking a look at few questions and see if we can answer some of them. On the chat, I answered a few. So that's cool. Okay, so you see the approach, the reason for this sessions is it's to make you understand the basics. Right now, the most common mistakes in all the trainings I have seen is they are unable to transfer the understanding of the basics. So the reason I am taking so much examples, the reason I'm trying to emphasize so much on these things, which is like the conceptual behind some certain reasoning. Once you understand that reasoning, only then you can actually intuitively apply correctly to, let's say, whatever we are doing, right? That's why conceptual understanding is important. And once we have understanding, then we can develop the depth of the coding, and that like we can do anytime, right? We are going to have more sessions more frequently, so don't worry about this. And we are going to have more specific related questions soon. I think next week we'll have a Q&A session, which is just for Q&A, which is going to answer most frequent questions which many people have. So yeah, stay tuned, and let's continue with the ML part which we are having today. Okay, so regression and classification and clustering, and what this means and how can we do that in the ML part. Let's just do that here. Okay, just a second. So going to the next slide, which is okay. So these are the common problems in machine learning. Okay, the common what do I mean by common problem? It's like, okay, when I'm predicting value, it's called as value prediction. Regression. If I'm predicting a class, it is class prediction. When I'm predicting, let's say, a possible class, it's like possible that is clustering. So there are also other problems which are like, oh, maybe predicting whether something doesn't match a pattern. That is outlier detection, which is, or fraud detection is nothing but outlier detection. Or there could be another problem which is like predict a value at certain time, not now, but at certain time in future. That is time series regression. If I want to predict class at something, so let's say when a certain user might get ill or something, that's time series classification. So this is how stuff is. Time series classification is what this is. Okay, so clustering, classification, and blah blah blah. uh let's see what else we have. Models and details, models and this thing. Let's just gain a deep understanding of machine learning. So remember, when we are saying y is equal to mx plus y is equal to which was like 1 0 1 2 up to 8. No, that was x, and y is equal to x plus 10, right? If you recall geometry, if you recall geometry, this thing, any line in 2D, any line in 2D is kind of like shown like this: y is equal to mx plus c, where m is slope, c is the intercept. What do we mean by slope? It's like if the line has a sharp curve or something. That is what I mean by slope. So when I'm trying to do machine learning, I am actually trying to learn what is the value of the slope. This is how you can intuitively understand machine learning. Machine learning is nothing but learning of value of m and c. If my functions, if I, let's say, plot a graph, okay, right now when I plotted x and y, it was a simple line, right? I mean, I created that data myself. The line was pretty simple. How did that line look like? Let me just open a whiteboard and plot a graph on it. Line was, let's say, it was like this. This was the line. Okay. Let's say I draw one more thing. I draw point X and Y like this. So the line is this. Or let's say I draw another this thing, which is this is a sine curve. So you see, depending on what kind of pattern is present between Y and X, we have to actually find out the function which can actually describe the curve completely. That's why we do data visualization, to understand what kind of data is present so that we can choose the function ourselves. If the data is not linear, we are not going to choose linear model. If the data is much more simple than what we thought, we are going to choose a simpler model. So this is what it means. We choose a function. Okay. We choose a function, and for that function, we calculate the value. How good is my model? What is the accuracy, and blah blah blah. And what is learned in that function? That's another question altogether. So in terms of y is equal to mx plus c, what do we learn? We learn m and c. Similarly, if my function is a circle, then I choose circle as a model. And what do we learn? We learn the center and we also learn the radius. If my function is parabola, I have to choose, I have to learn its foci. And I don't know what is the curve graph of parabola. I don't know. But we learn function parameters. That's what I was trying to come at. Machine learning is nothing but curve fitting. ML is nothing but curve fitting. That is how I can visualize it. The function is the function of the curve. So that is the function of the curve. And when we train the model, we learn parameters of the function. So when we do machine learning, which is y is equal to mx plus c for this problem, which we thought was, okay, where is this thing? This problem. Okay. So when we train this model, what it is going to have, it is going to learn a linear model. If the data is not linear, then we are going to have a bad model. But if it is linear, we are going to have a good model. So we have to check whether the model I have chosen is correct or not. So let me just execute this. So we have created linear model. Model.fit is training, and then model.predict is doing prediction. So when we simply compare what is the predicted value with actual value, we can see it is very accurate. Why is it accurate? Because data did not have any noise. Data was perfect. That's rarely the situation in the world. Data is quite noisy. There are errors in it. So most of the times, the accuracy is not zero. The accuracy is not 100%. Error is not zero. Okay. So there are few variables like this, which is there is a function called as vars. If I do vars of model, that will actually tell me what is the slope and what is the intercept. Okay. Here the slope is, what was the curve? Slope is 1. Okay, I'm gonna make it 3 into x plus 10. Okay, so 3x plus 10. And let me scroll down. Let me create the model again. Wait, what has happened? Oh, I didn't do reshape. Where is the reshape? Reshape is here. And let us execute. Reshape is must before we can do ML. Okay. So now let me execute vars of model. You see, the coefficient variable is nothing but the slope. Okay. And the error, the intercept is nothing but this intercept. And residue is nothing but error. How much is the error? It is 1 into 10 raised to minus 30 or 29. So as you can see, it's a very high accuracy. Why? Because the complexity of the data is matching the complexity of the model. Complexity of the data is matching complexity of the model. And once we kind of like meet that, that's when the error will be minimum. That's it. We have to take a look at the data, we have to take a look at the model, and we have to keep doing things like this until we arrive at a conclusion. Okay, arrive at a model which is uh, a good representation of patterns of the data. So let me open this stage. This is a document, and ML modeling is this. Okay, so let me just zoom in a bit here. Okay, so let's take a look at step number 1 in machine learning modeling. First, we have to do the experimentation. You see, when we begin doing ML modeling, we don't know. We don't know what's the right model. We might have to do lots of prediction and calculation and whatever it may be. We have to do lots of experimentation there, right? So this is what we mean. So for example, if I go to the slide deck for this, which is not here, I think it's one slide back. Yeah, here. So you see, whenever data is complex, we have to actually match the complexity of the data with the complexity of the model. Okay, so this is the top part. And this is a experimentation. We find it out through experimentation. So when we see that, oh, my model is too much complex for it, there is a word for it. When the model is complex but data is simple, it's called as overfitting. So it's kind of like overfitting is a good word. So maybe in terms of let's say, let me give you an example. Yes, let's call it enthusiasm is a good example. For example, let's say someone is dancing. Okay, so we have someone who is dancing. Yay! Okay, and there are certain steps. If let's say someone from India, we have Sunny Deol, who was known as a very bad dancer. So actual steps involve a certain grace, and a bad dancer who's dancing, he's not at all following the steps. He's not at all even moving tiny bit. He's not even doing any bit of effort. What is that? That is a very under enthusiastic dancer. So the actual steps are complex. He's not doing even smallest bit of this thing. It's same thing as underfitting. When the data is complex, model is simple, underfitting. When data is not complex, but the model is very kind of like much more complex. For example, let's say a step is simple, wherein you are simply standing. You are should be standing. It reminds me of an episode in Friends when Joey goes to become Al Pacino's butt. He is rejected because he is overacting with his butt. That is one of the episodes in Friends. I don't know whether you watch Friends or not, but that is the overfitting part. Overacting, over enthusiasm, over whatever it is. Like you are doing much more than intended. Same thing is here for the ML. When we are overfitting, it means I have to reduce my model's complexity. If I'm underfitting, I have to increase my model's complexity. And how do we find out if my model is overfitting or underfitting? There is a thing called as training and testing split. You will easily understand that conceptually if you think of your exams. So any degree, you have a final exam. Okay. Before final exam, we are supposed to study. And what are we supposed to study? We are supposed to study the material and gain the entire understanding of the material. If we have learned the proper knowledge, we should be able to answer any question based on the knowledge, right? Sometimes what happens is, like, if you are given practice test and you have final test. So practice test gives you how good you are in practice. And when you go to final test, that is what your final performance is. Okay. When you compare a student who got good marks in practice test and good marks in final test, that person is good, right? If someone who got bad marks in practice test, good marks in final test, that person had caught on, right? Here, what is this good and what is two separate test is doing? It is allowing us to compare our marks in two different tests, and it is allowing us to see who had studied late, who has studied afterwards, and blah blah blah. Same thing is here. If you find out error during the training and error during the testing, so let's say during the practice test someone had very low error but very high error in final exam, it means that person only studied in the practice for a small syllabus. That person did not study for the whole syllabus. He doesn't have actually deep understanding. He has only deep understanding of a very small problem. That is underfitting. So please try to spend time here on this table, and you have to understand and analyze how you have to, do the ML modeling. And once you do the ML modeling, this is what it means to have experimentation. You see, you start from a basic model. Okay, you start from a basic model, and on the basic model you train. So step number one is that. Step number two is you check how good your model is. Okay, you check how good your model is, and once you find out, oh, this model is not that good, maybe I'll try some other model. Let's see how good accuracy of that model is, and compare. Okay, this is what it is there in the code. You see, if I scroll down, this is on the noisy. Let's not go into the noisy part. Let's not go into the curve fitting part. Let's not go into the accuracy part. We have kind of like covered all of these things. Training and testing split, stats model. Okay. So let me just there is a more complex notebook, and let me share that in the Evernote document. Yes. So you see, if I want to check how good is my model's, let's say, accuracy, what I'll do is I will try different algorithms. I'll try, let's try simple algorithm. Then let's try a complex algorithm. Let's try even more complex. Let's try linear. Let's try probability based. Let's try hyperplane based. Now, because you are a beginner, you would not know what these algorithms are in the implementation thing, right? You would not know that. But once you spend time understanding this models, how they learn, once you spend time in understanding how your data is, you would be able to make a experimental choice, a choice which will allow you to choose a right model for the current data. So you see here the experimentation of different ML models to find out which one is best. Okay, so there are few products here which are good to know. All three are free. I think you can go for any of them. So weight and bias. So is it W and B? So weight and bias is a machine learning and deep learning term, or we have Neptune ML, or we have Comet ML. So what has happened to Neptune ML? Oh, it has become Neptune AI, I think. Okay, let me change my document. Okay. Yes. So this is weight and DB, Neptune ML, and there is this thing which is Comet ML. All of these things are for tracking experiments. I could be running multiple experiments. Let's see. So they all of them do this things like this. I could be running, let's say, multiple things, which is, let me just show which of them has easy graph. Okay, yeah, showing the image here. Okay, so you see, it could have, okay, I tried running this code 15, 20 times with different arguments, and in this situation, this experiment gave me a better result. So then I'll use only those values in the final experiment. So these three are the experimentation tracking. So you see, Thomas Edison's quote is very popular. I have found out 10,000 different ways my light bulb creation did not work. Right? But it's a bit corny quote. He was not doing blind experimentation. Okay. He was not doing, okay, let's take this material, not tracking, okay, what did I do? What did I not do? Which things I tried, which things I have not tried. He was keeping track of all of them. This is what it means to do experimentation tracking. Sometimes you might try something and your value might improve a lot, but then you have to keep track. Oh, I tried changing this thing. That's why it worked better. I need to do that more. Then you try something else on that experiment. Then that doesn't work. You go back. There are a lot of trial and error which has to be done. And that's where these tools like this are make a lot of sense. Then you have point number 4, which is like, do we create one model or do we create a combination of multiple models, right? Then you have optimization, then you have debugging, you have profiling, you have monitoring, you have accuracy, you also have model interpretability. So this is the entire stage. So this stage is pretty complex. Okay, it is not at all as simple as it is made out to be. It is very comprehensive, and without a deep understanding of what is ML, how to do it, and what does each stage do, how you have to code it, unless you don't know this, you will not be able to reach of stage number 7. So all of these stages you have to know, all of these. Okay, so this is kind of like how the approach is for ML. We have kind of like covered. So what we are going to do, we are going to create a Kaggle competition. We have not created that yet, but we will create a Kaggle competition for you guys to experiment. What are we going to do? We are going to create a fake data for you. Okay, so let's say the data which I create is, let's say, like this. Okay, so data is going to be like this. So there are few functions in scikit-learn. They allow you to create your own data. Okay, so for example, if I'm doing classification, inside classification we can create, let's say, choose how many data points are there. We can choose how many columns do I want. We can then choose out of these columns how many of them I want to be duplicates, how many of them I want to be just repeated as is, how many columns I want to be useful, and how many columns I just want as noise. How many, how much should be weightage and blah blah blah. There are lots of arguments here. So this is like create a data for classification. This is create data for regression. So here in Colab, even though you don't have this thing, right click and contextual help, you don't have. But when you hover over something, you do have the help thing. So let's see. We have number of samples, number of features, number of informatives, and bias and rank, and blah 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 blah. You have stuff like this. So we are going to create a regression problem, and for that regression problem, it's going to have a lot of data sets. Okay, in that, this thing is going to have an approach like this: choosing estimator. So this is an image of scikit-learn on official scikit-learn site. Here you start with a certain data points, and for regression, if your data is more than 100,000 rows and you have linear data, then you have to do something. If you don't have non-linear data, then you do something else. So we are going to give you 100,000 rows problem. You have to actually find out whether for that problem this algorithm is better, or this 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 is better. And you also have to find out, oh, this column is useful, this column is not useful, and all of these permutations and combinations you have to do quite a lot. Okay, so this is how we have to kind of like do this. So combination of lots of experimentations, and when we do this together, only then we get the final output. Okay, so that is the ML modeling part. So let me just go back a bit. Let's see, what should we kind of like cover. Okay, this slide is important. We have not covered this, but just a second. Yeah, these are all the 10 important things everybody has to know in the beginning. Okay, this thing is easy. We have seen what is the data. We have also seen the ML model, function, training, prediction. What is ML modeling? We just mentioned. We try different models and we compare, which is, this is the evaluation. So evaluation is a number which tells you how good is your ML model. And how do you do the evaluation? You do that with a thing called as metric. Okay, so maybe if you are ordering stuff on Swiggy or Amazon or something, the rating which is given on the object is the metric. Something which has high rating and high number of people who have given. So the rating and number of people, we use that to decide whether a object is good or not. Right? It's the same thing in ML model. We choose a metric. By comparing the metric, we decide which ML is better or not. And in ML modeling, we try, let's say, 5, 7, 8, 9, 10 different models. And for each model, we try 10, 20 different permutations and combinations of different values. Out of that, we choose the best combination. This is ML modeling. This is quite comprehensive. Today, we are taking overview of this. We are taking a look at overview of this, hence a big picture view. When we take a look at actual in-depth stuff, then it's going to be a extended course on actual ML modeling. So On Udemy, this thing will be soon uploaded. You'll have a comprehensive course which will talk about everything thoroughly and slowly. This is a overview, and in overview, it's not that deep because there is not enough time. But anyways, getting towards the conclusion, okay, in data science, we have to be three things. We have to be a combination of scientist plus engineer. We have to build the solution, and we also have to understand what we are doing. It's not going to be a blind solution. How do we understand? It's the we have to understand the maths part, we have to understand the algorithm part. Maths, I don't have to go into thorough depth until researcher level. No, as long as I can understand it myself and I can explain it to something what is happening, not not why is it happening, no, what is happening, and maybe why, a bit of why, or maybe a bit of how it is happening. That is more than enough. Why is it happening? What are the reasons? Why this thing was chosen? These advanced questions, we don't have to go into them, right? So this is the scientist, and we are, engineers, wherein we learn by actually doing. So I would really recommend everybody to solve problems, and the Kaggle competitions, which will drop you email about when we go live on it. Please try participating in that competition. You can actually see what is ideal accuracy versus what is your accuracy, what different trial and errors you can do, and how other people have done solve the same problem. You can learn all of that. Okay, so this is the experimentation of ML. So when you kind of like just keep doing this, you kind of like reach a stage of ML modeling. You start from data side. There are the stages here. You have data collection, you have data preparation, and you also have data visualization here. Then you have ML modeling. So ML modeling, this is a complex thing. There is another stage which is feature engineering, then ML modeling. And when all of this thing is done, as a result, you actually have a working model which actually has a quite good accuracy, which you can use wherever you want. And that's it. So this was the kind of like overview of ML. In terms of the content, it's like try to be comprehensive, but we can't cover everything. Why? Because this is a big picture thing. It is not a in-depth ML modeling part. We will try to have individual sessions on each stage so that we can go a bit more into details. But this is what is possible from our side. If there are any questions, you can please ask them on the chat. Otherwise, for today we are done for the day.
All right. Thank you so much, Achinkya, for the great session again. Yeah, please, if there are any other questions, drop them in the chat. But you can also connect with us on all our social media channels. You can ask questions there, and we will try to answer those. And generally, we will have more webinars going forward. Actually, next week, we plan a Q&A session. And we will have more webinars going forward. We'll keep you posted through email and as well through our social media channels. Just follow us, and we will post all our updates there. And today's session will be also available on our YouTube channel. So if you want to rewatch it, it's going to be there. I hope you enjoyed today's session, or the whole weekend actually. So day 1 yesterday, and now day 2. Have a great Sunday, everyone. We look forward to see you soon in one of the next webinars. And then, of course, also working on the first comprehensive online course, which will be published as well in a couple of weeks. And this will then cover everything what we do here in the webinars, plus additional content. So stay tuned for this as well. All right. Yeah, then bye, everyone. Enjoy your day, and we see you guys soon. Bye.